Okay, we're working on the plumbing problem, and um, because these problems keep getting longer and longer, I'm going to be doing less and less because by now you should be able to do most of this yourself. Again, we start with the bottom piece of math. Actually, we start with the output, and they want to know the tube type, number of feet, and the total order. These two are inputs, so they put up here. This goes down here, and this is the math necessary for that. We need to find out what the rate is, and the rate is logic. So we just simply do, well, if it's plastic, then a plastic rate, yada, 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 all the way down. So this is something that you should be able to do fairly quickly. And again, we have all our rates up here as constants. Then when I create my flow chart, let me move this down. All right, so then when I do my flow chart, I just do it the same way. So I have all my constants, my input, and then I start making each decision. When I make a decision, I do plastic first. I make sure I do my math and out my output. I test my first one first. So I type in plastic and 10 feet and plastic 10 feet and $3. And that's because it's 30 cents a foot. So then I copy this and paste it over here and change it to PVC and just keep working my way over. After I test PVC, I copy and paste it over to here, change it to aluminum, change it to copper, change it to bronze, testing and building as I go until we get to the end. Now at the end, in our problem statement, we don't have anything after else if. We don't have an else. And that's because we don't do problem solving in our or error checking and error trapping inside our problem statement. So this is where we end. Perfectly good when our user can understand what we're trying to do. But here we know that if they didn't type in the correct answer, we want to give them you typed in whatever they typed in, and then this is what they needed to type so that they can go back and do it correctly. We also want to go ahead and raise the error flag. So we change the error flag to 1. By default in Visual Logic, anytime you have a place in memory, its default is 0. So we don't have to do that up there. That's in JavaScript. But now we need to go ahead and mitigate it. So this right here is simply our error checking. All right, it checked it, but we haven't trapped that error. So now we need to go over here and trap it. And we simply do that with a decision. And we say that if, I should be copying and pasting, but error flag equals 0, meaning that no error has occurred, then I want this stuff to go in here. And if error does occur, meaning it goes down this way, I need to know. So I copy this and I paste it here. This pasting, putting this here, the same output in 2 different spots, does 2 things for me. One is when I test it, this thing better come up a second time, or there's a problem with my decision. And this right here is going to be a document right in my code. The other one's going to be an alert. There'll be 2 separate things. All right, let's test it to see if this thing works. So the first thing I'm going to do is plastic, 10 feet, and plastic, 10 feet. So I didn't break it. This still works. Now let's see what happens when I make a mistake. So here I'll type in plastic by mistake. It'll ask me how many feet, which is kind of irritating because an error has occurred. So you typed in plastic, only type in plastic. So I can see here where my error is. So when I re-put it in, it'll be correct. And then it tells me the same thing again, and then it ends. So we don't get any bad results over here. Now the other thing that we have is, why did it ask me how many feet? The only time I'm using the number of feet is down here, So there's no sense in asking that question until after we've proved that error equals 0. Now, in some other problems that we'll have, we're going to be doing some math in here, perhaps. And if we're doing math that requires number of feet, we can't move that out. But here we can move it out. So I'm going to go ahead and I'm going to cut this. And I'm going to paste it down here. Now, sometimes students think that, oh, well, Mr. Brady's giving me the green light to put input wherever I want. And that's not true. The only reason why we're putting it down here is because it doesn't make sense to ask this question if an error has occurred. So we're going to go down this way. No sense in asking that question, just like there's no sense in doing this math or doing this output. So now let's run it again. Again, first we'll see if we broke it. So you should always, every time you make a change, you should test it to make sure that, that it still works. Yes, okay, so it works when it's good. And now we'll make the mistake. And it says, oh, you typed in dog. You should have typed in one of those other things. Notice it didn't ask me how many feet. See, so that saved us from irritating the user by having them type in a value that they didn't need to type in, because the only time we're going to use this is right here. So we can do it after the error flag equals 0. All right, on to code.